Hello, this video is about lesson 7-6 from geometry, all about similarity transformations, okay? So I'm just gonna go over a couple of examples, okay? So let me just share this with you. So like I said, this is geometry lesson 7-6, okay? So the thing you need to know is the different types of similarity transformations. So there's a dilation. It's a transformation that enlarges or reduces the original figure proportionally. Okay, since a dilation produces a similar figure, a dilation is a type of similarity transformation. Okay, so basically you're going from one figure and you're either going from a small figure to a larger figure or a larger figure to a smaller figure. Okay. Dilations are performed with respect to a fixed point called the center of dilation, and then the scale factor of a dilation describes the extent of the dilation. And the scale factor, this is important, the scale factor is a ratio, okay, of the length on the image to the corresponding length on the pre-image. So this is another way to say it is the new over the original. Okay, the pre-image, another way of saying that is the original image. Okay, the letter K usually represents the scale factor of a dilation. The value of K determines whether the dilation is an enlargement or a reduction. Okay, so if it's greater than 1, it's going to be an enlargement. If it's less than 1, it's going to be a reduction. Okay, all right, so here we have an example of an enlargement. So we're going from this blue triangle, and then the green triangle is obviously larger. So it's an enlargement, okay? And then it says triangle FGH is dilated by a scale factor of 3 to produce triangle RST. And since 3 is greater than 1, triangle RST is an enlargement of triangle FGH, okay? So you can go by the scale factor, or you can just look at it and decide, okay, obviously from the first figure to the second, it was bigger, so it's an enlargement, okay? And then the opposite is true for reduction. The original figure is large, and then the second figure is smaller than the original, so that would be a reduction, okay? All right, so let's jump into some examples here. Okay, for number 1, it says to determine whether the dilation from A to B is an enlargement or a reduction, then find the scale factor of the dilation. Okay, so going from A, so this is triangle A and then triangle B. Obviously B is larger, so this is going to be an enlargement. Okay, so in order to figure out the scale factor, because that's just part of the answer, you have to find the differences in 2 of the vertices, okay? So if I'm looking at triangle A, I'm going to look at this vertice and this vertice. So this one is -4, -4, +4. Those are the coordinates. And then over here to this point is -2, +4. Okay, so I can see that the distance between those 2 points is 1, 2 spaces. Okay, so for A, the difference in the vertices is 2. Okay, I don't know if you can see that. Okay, it's 2. All right, and then if we look at B, we're looking at the corresponding vertices. So for this triangle right here, the corresponding vertice for triangle B is right here, and then the other vertice is over here. Okay, so we look at this and it's a difference of 1, 2, 3, 4 spaces. Okay, so the difference is 4. Okay, so remember we put to get the scale factor, we put the new image over the original image. Okay, so the original was A, so that's 2, and then the new one was B, which was 4. So 4 divided by 2 is equal to 2. So that is the scale factor. Okay, and then we already discussed that it was an enlargement. The scale factor is more than 1, so that's confirming that it's going to be an enlargement. Okay. All right, so let's look at the next problem. Second example. So same thing. Now we can see just by looking at this, going from A is this larger trapezoid, and then B is the smaller one. Okay, so this is obviously going to be a reduction. But we can verify that by figuring out the scale factor. Okay, so let's look at A. We're going to look at the corresponding vertices. So I'm going to look at this one here and this one here. Okay, so the difference is going to be 1, 2, 3, 4, 5, 6, 7. Okay, so for A, the difference or the distance between the two vertices is equal to 7. Okay, and then for B, the difference between this vertex and this vertex here is 1, 2, 3, and then it's halfway between the next one. So the difference is going to be 3.5. Okay. All right. So then for our scale factor, remember it's the new over the original. Okay. So the new one was B, which was 3.5, and then the original was 7. Okay, so you can simplify this by 3.5, and it ends up being 1 over 2. So the scale factor is 1 over 2, and it's less. The scale factor is less than 1, so therefore it makes it a reduction. Okay. All right, and just a quick note, if you didn't have, let's say these lines were at like at an angle, like something like this, if you're trying to find the difference on this line right here, you would have to use the distance formula, okay? So keep that in mind. These luckily worked out okay, but you may have to use the distance formula on some of these problems, okay? Keep that in mind. Okay, and that's all for lesson 7-6 for geometry. Thanks so much for watching. Hopefully this video was helpful to you. Okay, if you have any other questions, please let me know and I'll be happy to help. Thanks so much. Bye-bye.